This is the development of a handheld magnetometer prototype, which was conducted for the Michigan Moldwin Magnetics Lab, or M3L. Hello, I'm Diego Suazo de la Rosa, a freshman studying aerospace engineering and working for M3L. Today we'll first introduce what this project is before going into the details of how I approached it and then discussing the results. For starters, M3L studies space weather. This includes the magnetosphere, which is the space around the Earth in which vector-defined magnetic fields, such as the one seen in this picture of a magnet, are prevalent and active. Magnetic fields concern us since they can affect essential devices such as satellites out in space. The point of the project is then to develop a handheld magnetometer prototype for on-ground testing. The task was to make it using an Arduino and SPI, and the main goals were to make it functional, intuitive, and reproducible. The first semester of work was mostly spent on developing skills in different software, which was later used for the second semester of work, in which I wrote code, tested code, documented progress, and created a 3D model of the encasement for the prototype. The code is written for an Arduino, seen right here, which basically functions as the brain of the prototype. It uses an interface called SPI, or Serial Communication Interface, to communicate with the magnetic sensor, seen here. I was provided from a company called PNI. The code simply starts by doing some setup, asking the user for units, either decimal or microtesla, asking how it wants the data displayed, either through a liquid crystal display or on the PC monitor, and then starting a loop which only ends when the power is cut off. The loop simply has the Arduino asking the sensor for a reading and the sensor sending the reading. After the code, I tested and documented the results. I used a program called Fritzing to document the wiring diagrams of the prototype. I used an online repository called Git to store the code, and MATLAB to analyze the data, which I'll show later. Finally, I used SolidWorks to create a 3D model of an encasement for the prototype, a process that first begins with taking measurements before doing sketches like the one seen here, until eventually modeling the case, then overlaying parts, and then printing the case. The results were as follow. All criteria was met, although the functionality was a little varying. Some of the functionality showed that some of the measurements were actually inaccurate. In terms of intuitiveness, the design was made compact, and everything was made to be easily readable. Here is the Arduino, the sensor, and the display. A battery pack, since this is a handheld prototype, and an on and off switch. Again, this is a handheld prototype. We don't want to connect this to a computer or anything. Here's the liquid crystal display, which shows microtesla measurements. And it says time, X, Y, and Z, which again are the 4 things it prints out every second. Finally, due to the extensive documentation, this is a very easily reproducible prototype, and the code is also editable. In terms of functionality, we can see this video here that shows that this is in fact functional. You can see my hand pulling away a magnet, and then on the right-hand side, we can see the data was analyzed through MATLAB using an animated real-time graph of the readings from the magnetometer. It can be seen, again, how I am pulling away the magnet. After that, we have the 3D models made in SolidWorks for the case. The case is essentially made in 2 floors, the bottom for the battery and Arduino, and the top for the sensor and display. Again, display can be seen here. It also has holes for connections, seen here, and there's one small one here at the bottom, and it can be disassembled without screws. The case is made with lip and grooves that lock. Here's an overlay as previously discussed. It shows the Arduino, the battery, the sensor, and the display, and the inner chamber where all the wiring is held, and these 2 holes for more wiring. In the future, it would be good to implement a second sensor. The Arduino software and hardware also leave a lot to be desired, and they can be improved upon by using hardware like a Raspberry Pi or a circuit board. The code also needs to be improved upon since some tests led to questionable results. Upon all these changes being made, first, it'd be good to print the 3D case since we didn't get to do that, and finally, a commercialization of this prototype with the PI company could also be discussed. I want to thank everyone who made this project possible, and I want to thank you for watching and listening. For a more in-depth look at every part of the project, here's a length exhaustive report of the project and code.